Okay, everyone, good afternoon. Let's start. Just quickly go over what we did last time. So we first have the second version of the power of a point. And what is that? The power of a point, if it's inside the circle, it's r squared minus OP squared. Okay, why? Well, just because you can just connect the O with P, right? So by the definition, it is the PA times PB. But what's the PA? PA is just R plus OP, right? That's a PA. And what is a OP? What's a PB? Where PB is just R minus OP. So it's a difference of squares formula, right? That is for that. And the other one is for what happens if the P is outside, right? If P is outside of the circle, then what's the power of the point? Where by the definition is the PA times PB, but what's the PB? PB is just the OP plus R. And the other one, PA, is OP minus R. Again, it's a different squares formula, right? So we can get that. And this is here's just a couple of examples, right, for using this. Okay, what is that? You can take a look. What is this? So first we get the 8, right? And PB is 8, and the 10 is there, 8 is there. The other one is a 7, and angle P is 60, and we want to find the radius of the circle. Uh, okay. So first of all, I use the power of the point at P, right? You can figure out the CP, right? Just solve the quadratic equation, and CP is equal to 9. All right. And after that, then the thing is that you just consider this triangle. For this triangle, one side is 9, that's a CP. The other side, AP, is 18. And we know one side is half of the other side. And the angle between them is 60 degrees. And now that reminds us this is just the 30, 60, 90 right triangle, right? And then we get the angle of the C. So AC is perpendicular with the baseline, and then moving inside to the circle, and we know that AD must be a diameter, right? And that's a very nice problem. So it takes a couple of steps to figure out that, and then we work on the angle bisector theorem, right? Angle bisector. So that is just give everyone a minute. Let's go over that. Okay, give everyone a minute. All right, so if we have an angle bisector, then we will have, let's say, AB over AC equals BD over CD, right? There are a couple of ways to prove it, and here's one of this. You just draw a parallel line, right? Draw the parallel line CE parallel with AD, and you want to show that the AC equals AE. Okay, why? How you can do that? Basically, I want to show the angle 1, angle 2, they are the same. That's given because of the angle bisector. And the angle 1 can be switched into angle C. 1 and C, they are corresponding angle, right? And then angle 2 and angle 4, they are alternate interior angles. So so angle 3 and angle 4 are the same, and therefore it becomes a isosceles triangle, right? The rest of them should be fine. Okay. And finally, we work on this one. This is a hard one. It's a very hard question. Think of that again. So if I have angle 1 equals angle 2, right? Angle 1 equals angle 2. What happened? I want to prove that the, AX is equal to the BZ, AX equals BZ, Y. Okay. That's a hard one. Uh, the key idea is this. Okay. So first of all, if I know uh, angle 1 equals angle 2, that's the key idea. That's the main part here, right? That's the angle bisector theorem. So XD over XY equals ZD over ZY, right? That's the angle bisector theorem. And then from a numerator, I just multiply the same thing, XZ. So multiply this guy and multiply this guy on both sides, okay? And then you got the product here, and that is just the angle, that is just the power of a point, right? It's a power of a point of x with respect to the circle on the right, right? With respect to the circle on the right. So z x times the d, right? X, right? xd times xz equals xa times xy. So I switch this one to the other side. Same thing happened for here. And then let's make a switch, right, to this side here, right? And the magical thing is that after switch, xy cancel out, I get that, and then they cancel out, I got that one. It's a very nice proof. Okay. Anyway, are there any questions? Any question? Okay, very good. So let's go to let's do today. Okay. So starting from today, we are going to switch topic. So we cover the plane geometry for circles, right? You see that all of the material for circle, including how to draw the using the straight edge, right, and compasses to do the join, right? And now we're going to switch topic. I'm going to talk about for the next few lectures. I'm going to talk about the analytic geometry. Okay, this is also important. This is also important because when you study geometry, you need to know all different kinds of techniques, right? Not just the plane geometry, right? When I was at your age, I like plane geometry and not. This is my favorite subject. But on the other hand, you also need to know everything else because for some of the problems, uh, for one problem, you could use the idea from this side, but for the other problem, you could use the idea from the other side. But some of the problem can use idea from both sides. So that's why you need to learn different kind of ideas. Okay, so that's switch the topic. So we're going to do we're going to do some analytic geometry. Okay, so what is this? Well, analytic geometry is also called coordinate geometry. So some people call that coordinate geometry. Okay, well, similar idea, similar thing. So what's the purpose of that? The purpose of that basically says that we are going to set up an XY coordinate system. So we have the XY coordinate system, and then for the points, we have the XY. For the line, we have the equation. For the circle, we have the equation. So everything will be in terms of equations, right? And then we're going to use some algebraic argument, right? We're going to use algebraic argument and to solve problem in geometry, right? And you might feel it's unbelievable, you cannot do it, but actually for many of the problems, almost all of the problem in geometry can be solved by analytic geometry. Okay, that's cool. That's cool. But sometimes it's tedious, right? The work you have to show all of the works, all of the algebraic works. But I can tell you that if you're good enough, you can actually solve all of the geometry problem by using analytic geometry. So before we do that, just some warming up, some of the formulas that we're going to use for the rest of the couple of the weeks. All right, so first of all, suppose I have a straight lines and I have 2 points, x1, y1, x2, y2. And now the important thing is that how to get the slope of the line. I'm going to use m for that. It's a difference of the y value divided by the difference of the x value, right? I assume everyone knows that already. That's from the 06 algebra. So, okay. And then we have a couple of formulas. The first one is called the slope intercept. Intercept means the y-intercept. Slope intercept the formula, right? So we get the y is equal to mx plus b, right? M is the slope and b is the y-intercept, right? And also we have the point slope formula. This is the y minus y2 equals m times x minus maybe x1. Let's do the x1. We don't need the 2 here, right? Y equals y minus y1, and then m times x minus x1, right? And you can draw the picture here. So for this one here, right, this is the b here, and m is here. For the other one here, you draw the picture, right? You get a point, right? This is the point of x1, y1, and then you get the m here, right? So if you know the slope, if you know the point, and then you have the point slope formula, okay? But there's one formula that we didn't teach in 06 algebra, so I'm going to emphasize here. Let me give you another one here. Let's say suppose we give you not just one intercept, we give you two intercepts, okay? The x-intercept and y-intercept. Okay, so let's say, suppose I give you, let's see, we give you a 9 here, and that intercept here, the x-intercept, called that a here, the y-intercept, called that b here. So my question is that I want to find the equation of this 9. Okay, I want to find the equation of this 9. You can do that because you get the 2 points, right? You got the 2 points. If you have 2 points, you can get the slope, and then you can get the point slope formula, and you can finish that. But there's a formula which can, if you remember that, you can get that very fast, so that you don't have to go through all of the steps. The formula is actually very easy to memorize. It's x over the x-intercept and y over the y-intercept. That's equal to what? Okay, you might wonder why. You might wonder why. So I want to give everyone a minute, maybe half a minute. So how do you know this is correct? This is the correct answer. How do you know this is the correct answer? Everyone knows that? How do you know this is the correct answer? Where it's a correct answer because I just need to check that for 2 points. Okay, so I need to check for 2 points. Check for 2 points, right? Because a 9 passes through 2 points, and it's uniquely decided by 2 points. One point is that I can get a0, right? The other point is the b, not b0, 0b, right? The other point is the 0b. So let's check that. For the first one, a0, so x equal to a, I get a over a. Y is equal to 0, it's a 0 over b, and that's equal to 1. You see that? So the first point satisfies the equation, right? Second point, you do the same thing. So x equal to 0, 0 over a, and then y equal to b, b over b is equal to 1. So that's also fine. You see that? So both points satisfy the equation, and therefore, this is the equation for the straight line because one line is uniquely decided by the 2 points. So if we know that it passed through the 2 points, then it passed through all of the points over the line, right? So it's very easy to memorize that you get the x-intercept, y-intercept. It's x over x-intercept plus y over y-intercept. That's equal to 1. Okay, we're going to use that later. Okay. All right, another equation for straight line, that's called the standard equation, standard form, or we can say standard form. Standard form, and this is ax plus the by equals the c. All right, so I want to give everyone a couple of seconds. Let's think of that. We have how many forms? 1, 2, 3, and 4. 4 formulas for every straight line. You can have the 4 ways to describe that equation. Okay, right. And now we're going to talk about, suppose I have two straight lines, right? How about if the two straight lines, they're parallel lines, they are perpendicular line, and then what's the relation between them? Okay, and I think many of you all know that. So I have just have a quick review on those formulas. Okay, so what happens if I have let's say parallel lines, right? So let's say so I got the L1 and L2, the two lines, right? So L1 and is parallel with L2 if and only if their slopes are the same, right? M1 is equal to M2. So M1 is here, M2 is here. All right. And on the other hand, if I have two perpendicular lines, right? L1, L2, right? So you get the perpendicular. So if I have L1 is perpendicular with L2, then I'm going to have M1 times M2, and that's equal to -1. All right, so we can get that also. And what else? Okay, a couple of other formulas. We're gonna get the distance formula or the Pythagoras theorem. It's a similar, right? It's the same thing basically. So let's see the distance formula. Distance formula between a point x1, y1, and another point with the coordinates x2, y2. The distance is x2 minus x1, take a square, and plus y2 minus y1, take a square, and the whole thing, take the square root, right? So that is a distance formula. And then similarly, well, not similarly, it's another related problem where I'm going to get the midpoint formula, right? So the midpoint formula is that you get x1 plus x2 over 2. You get y1 plus y2 over 2. All right, so these are the formulas I think we can cover right now. Okay, everyone is good. And now we are going to give you well, let's just give you a one problem to see why we need to study analytic geometry. Or sometimes you have a geometry problem, and you sometimes some people can solve by using the pure geometry technique, but sometimes if you cannot, let's see, you can use a help from some other part. Okay, so let me give you an example. Okay, so let's see. Suppose we have a rectangle, right? Usually, for analytic geometry problem, the rectangle will be very popular. Why? Because the rectangle, you have a natural way to set up the XY coordinate system, right? So let's assume that you got the A here, and you have the B, and you have the C, and this is your D here, right? So you get A, B, C, D. So this is a rectangle. A, B, C, D is a rectangle. All right. And then P is just any point. So I'm going to put the any point P here. So this is my P here. P is just any point inside the rectangle, right? And then you can connect the PA, right? PB, and PC, and MPD, right? So you got that one here, right? And then I want you to prove that. So prove the following. PA square plus the PC square equals the PB square plus the PD square. All right, so this is a pure geometry problem, right? You have a rectangle, you have a P of any point, and then you got the 4 9 segment, right? So PA, PB, PC, PD. And the good news is that if you take a square of all of them, the four squares, right, they have such a very nice relationship. But how can I prove this? Okay, so I want to give everyone a minute. So you can try different ways. If you want to use a pure geometry problem, you can still do it. You can still do it. No problem. But I want to show you is a analytical way set up the XY coordinate system. So anyway, I give everyone a minute. I want you to try it. Okay, try that for 1 minute. All right. So can anyone figure out how to use the pure geometry without using analysis? If you know that, just let me know. You can send me a chat. So you say you can do it. Okay. Anyone can do that. Or if not, I'm going to use a different way to do it. Okay. So let's see. Let me try to do this. So the right triangle is a perfect problem. So if you see a question with a right triangle, that's a perfect way to set up the XY coordinate system, right? So I can make a rotation with a picture, right? I can move the picture in anywhere I want, right? Because I don't change the shape of the picture. So that usually is good. So now let me set up the XY coordinate system. So I call that, this is my X value, the X axis, right? And this is my Y axis. All right, my Y axis. And so for the X here, X is just 0, 0. For the B here, let me call that A of 0. So that means for the B, the X value is A, the Y value is 0. For D, the X value is 0, the Y value is B. Everyone's okay? So this is from just from 0, 6 algebra, right? So I'm assuming that you know that already. If you're not very comfortable with the coordinate system, you should go back and review review that previous course. Okay, and for the C here, C is just the A and B here. Does it make sense? Right? Everything is good. Now, how about the P here? I just call that XY. Well, I just call that XY. So let me just call that X and Y. Okay, let me just call that XY. And now the good news is that I can figure out the all of the squares. I can figure out all of the squares without any problem. So let's try that. So let's prove. Okay, what is the PA square? Is that difference of squares formula, right? Right? The distance formula, right? Distance formula. So the PA square just means I'm going to have x minus 0 square and y minus 0 square, right? Take a square root and take a square. So that is just this. Or you can say it is just the Pythagorean theorem. Okay, so I can get that. This is x square and plus the y square. That's a PA square. Now let's work for the PC square. PC square. Okay, so x minus a, take a square. Y minus b, take a square. Everything's good, right? You get the point P with the C here, right? So P and C, right? The difference of the X, take a square, and the difference of Y, take a square. And then you make an expansion. So let's say X square, 2X, and B square, Y square, 2by, and then the b squared, right? I call that first equation, second equation, where in your question, you ask me to add them together. Okay, it's just your question. I just add them together. So PA square and the PC square, what is this? Well, let me just do it. So you got 2x squared, 2y squared, right? And then I'm going to get let me put the square first, the a squared b squared, and then minus the 2ax minus the 2by. So far, so good. So I get the left hand side of the equation, right? I got this one. Everything's good. I got the left hand side. Now, just check the right hand side. Okay. So check the right hand side. I get the pb squared. What's the pb squared? Pb squared just means the x minus the a, take a square, and y minus 0, take a square. Again, I'm doing the PB, right? So I'm doing this one here, PB, right? That's a difference. That's a distance formula, right? The distance formula. So first one is x squared. Second one is a y squared minus. Oh no, wait a second. So I get the negative the 2ax and a squared, and then the y squared. All right. How about the other one, PD square? All right, I got the PD square. So I got the x minus 0, take a square, and then y minus b, take a square. Okay, I get x square here. I got the y square minus the 2by and plus the by. Let me call that 3 and 4. So I'm going to add the 1 with 2. That's the previous one. And I'll add the 3 with the 4. Okay. And I'm almost done because if I add them together, then you can see something magic. Okay. So x squared, that's a 2x squared. Y squared, that's a 2y squared. I get the a squared, I get the b squared. I minus the 2x minus the 2by. Can you check, are they the same? The first line is here, the second line is here. Are they exactly the same? Yes, they are exactly the same, right? And therefore, this is equal to the PA square and the PC square, right? Is that nice? Right? Is that nice? So this is a very nice proof by analytic geometry, right? By analytic geometry, right? So when you see something in terms of a perpendicular line, I would suggest you to try analytic geometry because that naturally can give me the XY coordinate system, right? And for the algebraic expressions, they are much simpler. Okay, they are much simpler. Okay, they are very easy to do the computation. Okay, everybody's good. Okay, and I'm gonna give you another example. Okay, so that's one example here. Let me try. Okay, maybe give someone some time. Right, so need you to understand the algebra here. There's nothing fancy here. You know, the good thing for the analytic geometry is that there's nothing fancy here, right? It's just a kind of a algebraic computation, right? You just need to be patient, right? You take the square of something, right? You do the multiplication of the polynomials. You just need to be patient, and eventually you will get the result, right? Eventually you will get the result. Does it make sense? Okay. All right. So I'm going to give you one more example. Let's see. Let's try this one here. Well, I think some time ago in 07 and geometry, I give you the following problem. So 07 geometry, I'm pretty sure many of you know this. Okay, I'm pretty sure. So let's see, we can have uh or we can have let's see suppose I have the right triangle, right? So we can get the right triangle here, right triangle here, right? So let's say this is a let's say I'm gonna use the A here, B here, and C here, and then you get the attitude here. So this is the attitude, right? Let me call that H here, right? And we know that. So we want you to prove uh, there are very nice uh, formulas involving the right triangle and then with the attitude to the hypotenuse, right? There are actually three equations. Let me just do one of this, and for the other two, you can do that in a similar way. Okay, so let's see. Suppose I want you to prove ch square is equal to ah times the bh, right? And I'm pretty sure many of you remember that. Last semester, we used a similar triangle to do it, right? So you can do the similar triangles, right? You can do similar triangles, you can do that, right? So let me call that first proof. Proof one, I'm not going to cover that because that's, you know that already. So you have the two similar triangles and then you can just work on that. So CH square is basically AH times the BH. Okay. But today, I'm going to use a different way to do that. Okay, so let's try that. So give everyone a minute. So can you try to use the analytical geometry? You set up the XY coordinate system. Can you do it? So I give everyone a minute. Okay, so I'm pretty sure many of you got the idea already. So what can I do is that I'm going to set up the equation since I have the right angle is here. If I see a right angle, I'm very happy because I can set up the XY coordinate system so easily, right? So let me do this. I'm gonna set up this one as my x-axis, all right, and this part is my y-axis. So I'm gonna do that way here. So y here. Okay. Now I can have my coordinates here. So A, let me call that the A0. So that means this is A here. B, let me call that B0. And C, let me call that 0C. Everything's okay? So I have their coordinates here, right? Okay. And now I need to figure out I need another condition, right? I use the first condition already, right? The first condition was the ch is the attitude to the base, but you also have the other condition. The other condition says the following: the AC is perpendicular with the BC. So let me write down the condition here. So given, okay, so AC is perpendicular with the BC, and BH is perpendicular with the AB, no, CH, right? CH, right? Uh, wait a second. AC, BC, CH, AB. Yes. All right. And so I need to use the second condition here, the first condition here. So in order to use the first condition, as I said earlier, the two perpendicular lines, how do I measure that? Where you measure by using a slope. So that's why in analytical geometry, you're going to use the slope a number of times. Okay. All right. So let me figure out the slope for the AC line, right? So what is this? What is the slope for this guy here? Difference of y divided by the difference of x. So I got c minus 0 divided by 0 minus a. So that's a negative c over a, right? Okay, similarly, I can do the other one. So let's see. Let me try to do the other one, the green line. Right, you get the other one here. So for the green line, I'm going to get the m of BC, which is a c minus 0, 0 minus b. So I get a negative c over b. All right, very good. And now the two of them, you got the slope of that, but the two lines are perpendicular. Okay, now we get the answer. So what does that mean? So the two of them are perpendicular. So that means I'm going to have the AC is perpendicular with the BC. And if and only if I get the MAC times MBC is equal to negative 1. Okay. And if and only if, let's see, I got negative C over A times negative C over B equals negative 1. Great. So what can I do here? I'm going to just multiply by the denominator. So I can have the following. I get the left hand side, I get a squared. The right hand side, I get negative a and b. All right, so let's think of that. What is a c squared? C is a c equal to ch. Okay, so c squared is just a ch square, right? Because c square, c just means it's a length of a ch, right? The ch had the length of c. Good. How about the other one? The other one, I'm going to write that to be a times negative b. But keep that in mind, the a is just a ah. The a is just the ah. But for the B, what's the B here? But be very careful. The point B is to the left of the orange. So B is a negative number. And so negative B is a positive. Does it make sense? We have to be careful. We have to be sensitive with a negative number when we do the analytical geometry, right? For pure geometry, we don't worry about the negative numbers, right? Everything is positive. But so be very careful, right? The b here, b is a negative number. So negative b is a positive, and actually negative b is your BH. All right, so don't forget that. So I'm going to emphasize the negative sign here. Negative B is the BH. And then we are done. Okay. So just want to give everyone one more minute. So here is another nice proof, right? With you, which use analytic geometry. So you use the nines, right? We use the nines, and we use all kind of things, right? For every nine, you have all of the four ways to set up your equation, right? Is that good? Okay, I hope you like this kind of the idea, the strategy here. Okay. So I just want to use this example to show you that it's good to learn a different technique, even if sometimes it's boring, sometimes it's tedious. Many students just told me that in the past. Analytic geometry is very, very tedious because you have to do all of the computation, right? Not like the pure geometry, right? It's just proof, right? Theorem, proof, theorem, proof. But it's different, but it's useful, right? It's different, it's useful. Okay. All right, everyone's good? Give everyone one more minute. Let's go over that. Okay, and since for the topic for this course, the main topic, our main topic is about circle. So I'm going to introduce the circle. All right, let's go. So it's not always like as I say that if you see a perpendicular angle, perpendicular line, we're happy, but it's not always, right? Sometimes you have to have circle, right? So if you have circle, things does not go that way, but still it's not bad, not too bad. So we can still do it. So let's see. Let's go to the circle. Okay. So I'm going to get the circle. The first thing is that we need to get the equation of the circle. Okay, so let's try equation of the circle. Okay, and I think someone show me oh, that's the okay, let's do that. So I'm gonna get this one. Oh, maybe I should. I'm still trying this. It's not my. Okay, good. I want to have an endpoint here. Very good. So let's see. Suppose you have a circle in this way, right? And let's see. You go here, and you get here. All right. And let's say the center here has a coordinate of this is h, and the x coordinate is h, the y coordinate is k. So I got the h of k, right? This is the center. Let me call that O is the center, right? And the radius, so let me use the radius is the r. Okay, so I give you the center of the center. Center is hk, right? And the radius is r. Okay, my question is, I want to figure out the equation. Find the equation of the circle. Find the equation, or maybe a equation, because they are not many. You know, it's not unique. You have different ways. You have different forms to write the equation. So find equation for the circle. Okay, everyone understand my question? Because that's just the warming up, right? When you have equation, when you have a circle, you know the center, you know the radians. How do you write the equation? Okay, give everyone 10 seconds. So let me pick a point. Suppose I pick an arbitrary point. Let me just put that here. So I got the point here, x, y. So pick an arbitrary point from the circle, and then connect the circle, connect the point with the p here, right? And then I want to, and so P, keep that in mind. P is any general point, not the spatial one, right? You have a P first. The P is just any point from the circle, and then you connect the OP, right? And so I want to figure out how to figure out the OP. Well, distance formula. Does it make sense? Right? O is here, so the center is the. Let me write the O here. The center is O, and HK here, right? And then your P is XY. So you got the 2 points with the coordinates, and then you can figure out the distance. So the distance here is actually equal to X minus H, take a square, and then Y minus K, take a square, and eventually I need to take a square root. And that answer is supposed to be R because this is just a radius of the circle. Does it make sense? Everything's good? Excellent. And now I take a square both sides. So I square both sides. I can have X minus H, take a square, and Y minus K, take a square, and that's equal to R squared. And that is our formula for, it's called the standard formula. It's called the standard formula or standard form for circle, right? If you know the center, if you know the radians, and keep that in mind, this is negative. So I'm going to emphasize that minus, so X minus H, Y minus K. That's called the standard form of a circle, okay? Everyone's good? And we're going to use that a lot today, okay? We're going to use that a lot. Okay, just give everyone a few seconds. Try to memorize that. It's X minus X value of the center. Take a square. Y minus the Y value of the center. Take a square. And equals the right-hand side is the square of the radians. Okay, the square of the radians. Okay, very good. So I'm going to give you some example. Okay, so here are some examples. Let's see. We want to find the center and the radians of the circle of the following circle of each circle, and also draw the circle, and also draw it. Okay. First question. How about I have x minus 5, take a square, and then y minus 7, take a square. That's equal to 81. Okay, that should be very easy. Warming up. Okay. Can you answer the question in 5 seconds? Okay, if you want, you can type in the chat. Okay, so what's the center? And where's the center? And where's the radians? The center and the radians. Okay. Where by the standard form, the center is, you take the negative, no, you take the positive of that. Why you don't take the negative? Because the formula has a negative sign here. Can you see that? The formula has a negative sign here. So actually, if you have a negative 5, the x value of the center is actually positive 5. All right? The x value of the center is actually the negative sign of that, the negative 5. So it's actually positive 5, the x value. Okay, similarly, the y value is 7. So the center is 5, 7. Okay, radians is just the square root of 81. Why I take a square root? Because in the standard form, the right-hand side is the square of the radians. So if the square of the radians is 81, the radians is just a square root. And I pick the positive sign, right? Don't worry about the negative because the radians is positive. Very good. Draw the picture. I leave the work to you. It's easy, right? You get the center and you get the radians, and you use that composites to finish that. So I don't draw that here because drawing the picture is not easy for me. Okay. So let's see. Next one. How about I have x plus 5 square, and then plus x plus 3 square. That's equal to 36. Okay. Find the center. Find the radians. Give everyone 10 seconds. Okay, so let's see how to get that. All right, so I'm gonna have the center is the, is there someone say 5 and 3? Anyone say that? Where it should be the negative. Does it make sense? Right? It's not. It's not the so if you write the 5 and 3, that's not right. You have to take the opposite of that, like the previous part here. So don't forget the negative signs. I'm gonna have the negative sign and negative sign here. So it's -5, -3. Okay, -5 and -3. Don't forget that. And then the radians, that's easy. It's a square root of 36. That's equal to 6. Okay, next one. So far, so good. Next one is not easy. Let's see. I'm gonna give you the equation. Sometimes is given in a different way. Okay, sometimes it's given in a different way. So I'm gonna have the x squared plus the 10x and then plus the y squared minus 8y equals 8. So for this question, the hard part for this one is that it's not given in the standard way, right? It's not given in the standard way. So how do you write that in the standard way, right? So what's called the standard way? Let's go back to here. Standard way is here. So this is the standard way, right? You're going to write your left-hand side in terms of the sum of two squares, okay? You're going to write that in the sum of two squares. So can you do that? This is a little bit hard. I give everyone a minute. Okay, and then I'm going to show you how to do this. Excuse me. All right, I think many people got the answer already in the chat. Excellent. I like that. So very good. So a couple of people get the answer already. Yeah. So the idea basically is called the completing the square. So I need to. So let's see how we can do this. Uh, it's called the completing the square. So I don't have time to respond to everyone, but just a few of you. Okay, so how do I complete the square? How do I complete the square? Well, so the idea is that where if you have a square like let me show you that. So if you have a square like x plus a, take a square. The first one is just a square, x square, and then 2x, and then you have the a square here. So if I want to make a square for this one here, the 2a should be my 10 here, and a is just a 10 divided by 2, right? And I need to add the square on both sides. So what square should I add? I need to add the 5 square. Does it make sense? So the first one I can do here is that x squared plus 10x, I need to have add a 5 square. Okay? So that means for the right hand side, I need to add a 5 square. Does it make sense? I add a 5 square on both sides so that I know this guy is the x plus 5 square. Okay, that's the tricky part here. So you're going to add some square to both sides so that you can complete the square, right? If you're not quite sure about that, don't worry about that. Just go forward, right? So later on, you're going to learn that. Okay, you're going to. I think that kind of technique will be introduced in 07 algebra. So this is it from 07 algebra. If you haven't learned that yet, you will learn that later on. Okay, but or right now, it's not too bad. Okay, second one, you're going to add 8 over 2, take a square. So that means I'm going to have 8 over 2 take a. So the key idea is that you always pick the coefficient of x, divide by 2, take a square. That's the number you need to add, right? So I'm going to add this guy here, and that's a y minus 4, take a square. Okay, let's do the right hand side. 8, 5 squared 25, 4 squared 16. 25 plus 16 is 41. 41 plus 8 is 49. And that gives me the 7 square. And then we are done. Okay, why we are done? Because the center is -5 and 4, right? The radius is 7. Okay, so give everyone some time. Couple of seconds. Everyone's good? Excellent. Okay, so I'm going to give you some other problems. So let's say, let's see. I get suppose I have A is -3, 2, and B is 2 and 0. I want you to find find an equation of the circle with AB as a diameter. So for this question here, and you know the diameter, okay, it's given. The diameter is given, right? So assume that I got the A here, right? Okay, so I have the A is a 3, 2, right? A -3, -3, 2, right? And then B is 2, 0. So let me say that the B is 2, 0. And I want a circle going through this way, all right? Or maybe I can do it backwards, okay? Because it's hard. After I get that, it's hard to draw the picture. So let's see. Let's go backwards. Okay. I can get the circle first. All right. I can get the circle first, and then I can tear A and B, right? That makes things much easier. Okay. So let's see. I got the A here. Oops. Let's see. I got A here, and then maybe this is the B here. B is in this one, and this is the diameter. All right. Okay. So you got the A, you got the B, right? And then how can you use AB as a diameter, and you can construct the circle, right? I want to figure out the equation of the circle. Okay. So the key idea is that where you know the diameter, and so you can figure out the radians, right? You can figure out the radians. And after you figure out the radians, you can figure out can you figure out the center? Where's the center? Well, the center is here, right? The center is here. But how do you find the center? Midpoint formula. Does it make sense? All right, you get the midpoint formula, you can get the center, and you use the distance formula to get the diameter, and then you can get the radius, and then you can get everything. Okay, give everyone a minute. Let's try that. Let's try this. So, well, we can do it together. I think we don't have much time left, so just do that. AB, suppose AB, so I'm going to have the -3 minus 2, take a square, 2 minus 0, take a square, all right? So I get 25 plus 4, right? So I can get this is 29. I can get square root, right? Uh, right. So we get that 25, right? 25, 25 plus 9. So that's easy. Uh, oh, yeah. So 25. Yeah. Right. Everybody's good. And now, so I can have the radians is just half of that. Radians is AB divided by 2. So I can get 29, take a square root, and divide by 2, right? And then you can you can do the center. Where's the center? The center is different squares, the midterm formula, right? The midpoint formula. So you get this one divided by 2. 2 plus 0 divided by 2. So you can get it's a negative a half, right? Negative a half. And then the other side is the what is that? It is just a 1, right? Negative half, and it's just a 1 here. All right. So what's your final answer? The final answer will be x. The value for the x value for the center is negative, but if I want to write down the equation for the circle, it becomes positive because I switch the sign. So this one plus 1/2 take a square. The other one is y minus 1 take a square. The right hand side should be the square of this guy. So it's a 4 here, and numerator is 29. Is that good? Okay. Let's just try one more example. All right, let's just try one more example. So let's see. Suppose again, where, excuse me. So I'm going to get that one first. All right. So let's see. Oops. Oh, we don't have time. That's so fast. Anyway, so the basic idea is that let's see. The basic idea is that, well, let's say, suppose I give a point, right? So suppose this is a point here, right? And I'm assuming that this is a point. Let me just say 2, maybe 3, right? 2, 3, right? And then I assuming that you get you have something like that. So you have the let's see. So you got the 2 is here, right? And let's see the y, maybe the x value, maybe x-axis maybe here, the y-axis maybe here. So here is the circle is tangent with the y-axis. Okay, the circle, and I want you to find the equation. Find the equation. All right, so I couldn't write down the whole question, but you understand, right? You can see from the picture here. I got the circle, the center is 2 and 3. And this circle has a radius. I didn't tell you the radius. I just tell you it is tangent to the y-axis. So we're going to use a tangent line. All right, but it's a special tangent line. The tangent line is a vertical tangent line. So I want to find the equation. Can you get that in just 10 seconds or 15 seconds? Okay, tell me what's the radius of the circle by using the tangent. Since it's a tangent to the y-axis, so basically this is a radius, and the radius is just equal to 2. Can you see that? So if it's tangent to the x-axis or it's tangent to the y-axis, you can read the radius very, very quickly, right? That's just equal to 2. And then you get the answer immediately. So what's the answer? You got the x minus 2, take a square, and then y minus 3, take a square. That's equal to the 2 square. And then we are done. right? Right. All right. So I think that's all. Okay. Oh, wait a second. Oh, I think yeah, I'm right. I'm right. Yeah. Right. So I guess the horizontal line may not be here. Horizontal line because it's 3, so I should draw the horizontal line maybe somewhere like this because it's 3. 3 is bigger than 2. Can you see that? Right. So that's a horizontal. So that's a correct picture. My previous one was not right. Right. So 3 is there. Good. Everything's good. Right. All right. So I think that's all for today. That's all for today. Okay. That's all for today. Very good. So that's all for today, and I'm going to see you next time.
Bye. Thank you.
Bye, everyone.
Thank you.
Yeah.
Thank you. Bye.
Bye.